Hi everyone. In this session we are going to discuss moving charges and magnetism. A toroid core has inner radius. Let me change another color. Inner radius r is equal to 0.24 meter and outer radius 0.26 meter. Current I is equal to 10 amperes flows through a wire having number of turns n equal to 2500 around it. Find the magnetic field inside the core is equal to. Find the magnetic field inside the core is equal to. So, in terms of small r, capital R, I, N, we need to establish a formula. Let us see. We have average radius R effective is equal to R plus R by 2, which is 0.24 plus 0.26 by 2. This is 0.25 then meters. Then magnetic field induction B inside the core is equal to mu naught Ni. That's why I change it to small n this one. This is cap number of turns with capital N. Number of turns per unit length is with small n. So mu naught n by 2 pi r into I. Mu naught 4 pi into 10 to the power of minus 7. Answer is in pi only, you no need to change. 2500 into current 10 amperes by 2 pi into R value 0.25. 2 pi will go 2 times and 2 yeah, why should I, okay. Let us simplify. This is 2 into 25 into 10 to the power of minus 7 and plus 3 by 2, 0.25. 0.25 will go here, 25 1 times, so 100 times it will be. Another 2 zeros, so 10 power minus 2 will be there into 2 in. Oh, where is pi? Mu naught, total length is 2 pi r only, right? There is no pi, yeah, okay. Pi cancel, 2 into 10 power minus 2, so option is in C, Tesla, correct only. Pi cancelled. I thought that by mistake I cancelled or yeah. 3 parallel wires ABC carrying currents A equal to AB, IB, IC and figure are placed next to each other. The magnitude of force on a length L of a wire A, which is at 2D distance from the B wire, and some more conditions are there. If D2 is equal to 2D1, oh, and IB is equal to IA, and IC is equal to 4IA. Let me do one thing. First of all, this is one conductor. This is another conductor at a distance D1. Next, another conductor at a distance D2 is equal to 2D1. Okay, next IA equal to IB. This is IA and this is also IA only. As he said, IB is nothing but IA only. Okay. Next, IC is equal to 4IA. This is equal to 4IA. Okay. Now, the force on the conductor wire A. Force on A. This is A wire. Force. See, all the currents are not traveling in the same direction. That also I noticed. See. This is this way. Force between two parallel conductors, what is that? First of all, I want to say force on A because of B is equal to, for the given length is equal to mu naught I1 I2 by 2 pi d. 2 pi r actually I can write, so 2 pi d. So this is mu1 mu naught IA into IA same into IA by 2 pi d1 2 pi d1. This is first one. And parallel conductor, so attractive force, so this is FAB, and this must be repulsive because unlike currents, so automatically repulsive. This is FAC. FAC by L is equal to mu naught IA. IC is IC. Okay, I will write IC only, and this is 2 pi the distance d, which is equal to mu naught IA 4IA by 2 pi into 2d. So this 2 will go 2 times. So this is 2 times of mu naught IA and IA by 2 pi d1. So that means this force is 2 times of this one. So on subtractions, because opposite, so on subtraction 1 time of IAB will come. So F net is equal to mu naught by 2 pi into d1 into I1 square or IA square. That only will come, right? And on the given length, so you can multiply with L, so into L. So option B, yeah 6. Din. Let me check the option. This is, oh, total distance 3D. My mistake only. Yes, it's my mistake. 2D is up to here only 2D. Here to here is 3D, right? So total you have to take. Only yellow color one is wrong. Remaining are wrong. Let's continue from here. So mu naught IA 4IA by 2 pi into distance is up to here 2d1 and up to here d1, so total 3d1. So this will be 4 by 3 of mu naught IA square by 2 pi d. So net force is equal to F net is equal to FAC is stronger minus FAC FAB, okay, into L. So that is equal to 4 by 3 minus 1 into 4 by 3 into minus 1 into this is mu naught IA square by 2 pi d. So 3 1, so this is 1 by 6 mu naught IA square by 2 parallel conductors, each 50 meter long. L is equal to 50 meter. Separated by distance 0.2 meter. Experience a force 1 Newton. If the current in the first conductor is twice, to the second conductor, then what is the current in the second conductor? I2 is equal to question mark. Force already given, right? So we can take like this. F by L is equal to mu naught I1 I2 by 2 pi d. F is 1 Newton, L is 50 meter, that is equal to 4 pi into 10 to the power of minus 7 into, I want I2. So I1 can be written as 2I2 and this is I2 by 2 pi d. 2 pi into d value, distance of separation 0.2 meter. So 2 pi will go 2 times and that 2 will go 0.1. So okay, slow, cool. 0.2 cross multiplication I am doing by 50 into 10 to the power of plus 7 by 4 is equal to I square, I2 square. Yeah, slow, cool, happily. 2 zeros let me take out. 2 zeros if I take, 1 0 will give you 2. 3 zeros I will take. Yeah, 3 zeros. Then 200 by 50 into 4. Why? We'll do slowly, happily. 0.2 into 10 to the power of 7 by 54s are 200. Yeah, equal to I2 square. So I2 is equal to 0.001 because 22 will go 0.1 times. 0.1 by 100 is this one into 10 to the power of 7 under root. So that is equal to 10 to the power of 4 under root. That is equal to 100. Next. A long solenoid with 10 turns per centimeter. Long solenoid. Number of turns per length is 10 turn per centimeter. It should be remembered like that. And the radius R is equal to 8 centimeter. Carries a current I is equal to 7 milliamps into 10 to the power of minus 3. A current carrying straight conductor is located along the central axis of the solenoid. A current carrying straight conductor is located along the central axis of the solenoid. Okay. If the direction of resulting magnetic field is 60 degrees to the axial direction at a point 5 cm from the axis, total radius is 8 cm and at 5 cm direction is 60 degrees axial direction. Okay. And the solenoid along the radial direction. If the current in the conductor is, so this is 8 cm radius solenoid. And here is one straight conductor. This is actually 8 cm radius. 8 cm. And at 5 cm only, suppose magnetic field because of this solenoid, I will show you with yellow color. Magnetic field due to solenoid will be this way, suppose. Magnetic field will be with the solenoid. And current due to this conductor, I will show you with this, yeah, either into or dot, whatever, into. That means into. Then resultant, so resultant is 60 degrees. Resultant is 60 degrees. So I can take up magnetic field, they are perpendicular, right? So tan alpha is equal to q sin theta by p plus q cos theta I can use. Even that also not required. I can directly go by y value by x value. I can see what is that angle with which one, that I need to check once. If the direction of resultant magnetic field is 60 degrees with the axial direction, this is 60. That means I have to write B of the wire by B of the solenoid. Yeah, opposite is that only, right? That's why. B of the wire by B of the solenoid is tan 60. Tan 60 हमारे देश में √3. So B of the wire is equal to √3 times of B of the solenoid. B of the wire is, what is he asking? Then the current in the conductor is, okay, mu naught I by 2 pi r is equal to mu naught n by L into I in the, this one, I in the wire. So you can easily simplify. Mu naught will go. What are the things? IW is equal to 2 pi r into n into is by L. So I'll write 2 pi value, okay. Why is he given √2 value and √3 value? Sometimes he will give. And r value, r. Where is r? Okay, √3 is here. Oh, I didn't write √3 here. Yes, so this is √3. Yeah. R value 5 centimeter. Okay. And 5 centimeter, 5 by 100 I have to write. And number of turns 10 per centimeter. Number of turns per centimeter 10 per centimeter. In the by I have to write 10 to the power of minus 2. Then these two will go. Okay. And number of turns per centimeter. Okay. Into is. What is the current? 7 milliamps. 7 into 10 to the power of minus 3 into root 3 value 1.7 into 1.7. So on simplification, I will get like this. G 3.74 amperes. This is the way you need to do this type of problem. Next. Long solenoid has 70 turns per centimeter. Long solenoid have 70 turns per centimeter. Carries current I. An electron moves with the solenoid in a circle of radius r is equal to 2.5 centimeter perpendicular to the axis. An electron moves within a solenoid in a circle of radius 2.5 centimeter perpendicular to the solenoid axis. Okay. This is solenoid, suppose, and an electron is also moving in a circle. If the speed of the electron is v is equal to 4.4 into 10 to the power of 6 meters per second, the current I in the solenoid is, current I is equal to how much? Again, a long solenoid has 70 turns per centimeter, carries current I. If an electron moves within the solenoid in a circle of radius 2.5 centimeter perpendicular to the solenoid axis, okay, if the speed of that is equal to, okay, and here some things are missing because of this. Maybe I can feel like this. What is that? Is suppose it creates a magnetic field like this, B. In this, suppose an electron enters with a velocity this much, v velocity, then it makes a circle r is equal to mv by bq, and mv by b value is mu naught ni into q, which is equal to r. That means I is equal to mv by mu naught nr into q. Think so. So then only it can make circles, right? That in that sense. Let me change the color for simplification and substitution. I is equal to mv, m 9 into 10 to the power of minus 31, velocity 4.4 into 10 to the power of 6 mv by mu naught 4 pi into 10 to the power of minus 7, 4 pi into 10 to the power of minus 7, mu naught ni, n 70 per centimeter, 10 power minus 2, r also in centimeter, then no need to write. If r is also in centimeter, no need to write. Per centimeter, and r is equal to 2.5 and q equal to 1.6 into 10 power minus 19, 1.6 into 10 to the power of minus 19 charge of electron. So it simplifies to, you can do it, no? Why should I waste time? 112.5 milliamps. So this is the procedure. Next, a toroid has a core of inner radius 24 centimeter and outer radius 26 centimeters. Obviously R effective is equal to 25 centimeter, around which number of turns is equal to 2000 turns of a wire or wound. Okay. And if the current I is equal to 12 amperes, the magnetic field inside the core of the toroid B is equal to mu naught Ni, which is nothing but mu naught N by L into I. Mu naught value 4 pi into 10 to the power of minus 7, number of turns 2000, length is 2 pi r, 2 pi into r value 25 centimeters. N value number of turns only, centimeter should be converted 10 power minus 2, n is number only, and mu naught, okay, and I value 12 amperes. So should be simplified, 2 pi will go 2 times and blah blah blah. Force acting on an electron moving with velocity v in a magnetic field B. Force acting on an electron, yeah, that is F due to magnetic field is equal to Q into V bar cross B bar. You need to know vector form basically. Later the shortcut one BQV, whatever you pronounce. So remember. Next. Long wires, two long wires with no contact are placed perpendicular to each other. Two long wires without contact, they are perpendicular. I1 and I2 currents are going, I1 and I2 currents are going through these wires respectively. The magnetic force on a small length dl, magnetic force on a small length dl of the second wire, okay, second wire situated at L from the first is proportional to, it is at a distance L is proportional to, okay. At a distance L, what is the magnetic field? At a distance L, what is the magnetic field due to 1? That is equal to mu naught I by 2 pi r. So 2 pi L will come. Okay, okay, second conductor, right? I will change like this. This is first one, that is second one. Because usually horizontal one is the first one, right? So on the second conductor only he said. The magnetic force on a small length dl on the second wire. Okay. This is first one's current. Yeah. Now force on the second one. Force on dl on the second one, that is equal to bill, B I L, bill, mu naught I1 by 2 pi L I2 into dl. This is force F. He is asking, is proportional to mu naught constant, 2 pi constant, so F is proportional to I1 I2 by L into dl. So I1 I2 proportionality is preferable here. Circular coil has 10 turns, N is equal to 10 turns. Radius R is equal to 10 centimeter. Is placed in a uniform magnetic field, B is equal to 0.1 Tesla. Normal to the plane of the coil. If the current in the coil is 5 amperes, the magnetic field of the magnitude of the torque on the coil is, torque tau is equal to, okay, torque tau is equal to Bina. Okay. Before that, Bina cos theta is also there. We have to check whether it is experiencing torque or not with this. Later you can go for the calculation. That is, you see, if the current of the coil is 5 amperes, Tesla, normal to the plane of the coil. Coil, plane, this way magnetic field B. Then cos 90 degrees will come. Cos 90 will be 0. So we need to go for that option. So don't waste your time in calculation. First, see, plane with plane angle theta, that only Bina cos theta formula. With plane only that angle. So torque will be 0 in this case. Torque will be 0. Right? Next. Figure below shows 3 circuits consisting of concentric circular wires, straight radial lines. The center of the circle is shown by the dot. Same current flows through each of the circuit B1, B2, B3 are the magnitudes of the magnetic field at the center. B1, B2, B3. Okay, which of the following is true? What are B1, B2, B3s? In the picture only B1 is there. The other things are not there. 3 circuits consisting of concentric circular wires. Maybe diagram misplaced. Let me check it up. Diagram is different. Oh, 3 pictures may come, I think. Yes. Okay. So these are the 3 pictures. First one is B1, second one is B2, third one is B3. We have to compare all the things, right? Okay. So B1. First one. Here, this one's the straight conductor through origin or O not going to produce any magnetic field. Only the half circles they are going to produce. So the one by one slowly we'll do this one and this one, going this way and going this way and here. So the lower part one lower part 1 outwards, upper part 1 also outwards, both are outwards. So it is going to add up and outwards field will come. So mu naught I by 4r, no, 4 of 1 by r plus 1 by 3r. So by 4, mu naught I by 2r is the formula. By 2 we have to do, no, that's why. So its simplification is mu naught I by 4r of 1 plus 1 by 3. 3 ones are 3 plus 1, 4 by 3. 4 by 3. So this is going to become mu naught I by 3r. First one over. Now second one. Second one is currents are opposite. Currents are opposite is going to get a subtraction. B2 is equal to mu naught I by 4r and taking common 1 minus 1 by 3 it will be. So 3 ones are 3 minus 1 is 2 by 3. 2 by 3 means it will be mu naught I by 2 3s are 6. 2 3s are 6r, because in the numerator 2 will come, that 2 and this 2 gets cancelled. Yeah, this is B2. And what about B3? B3. R circle is there, 2R circle is there, and 3R circle is there. All are going to getting add up. So B is equal to, B3 equal to mu naught I by 4 times of 3R, because 2R is the formula but semicircle, so 4R, plus mu naught I by, this is quadrant of a circle, 2 4s are 8 into 2R, plus mu naught I by, I'll tell you, full circle B value mu naught I by 2R, half circle mu naught I by 4R, and quadrant mu naught I by 8R. Those I used. And this is also quadrant, so 8 into R. So this is mu naught I comes out, and in the denominator 8 2's 8 8, only 4 I can take common, 4R I can take common, so it will be 1 by 3 plus 4 will go, so 1 by 4 plus 1 by 2. Yeah, so this is 12 LCM. 12 LCM. On the top it will be 4 plus 3 plus 6, then 13. So it is 13 by 48 mu naught I by R. So you need to compare with this. One is 1 by 3, one is 1 by 2, and 13 by 48. 12 table roughly 1 by 4. Yeah, 1 by 4. 1 by 4 means 0.25. This is B3 and this is B2. This is B1. This is 0.66. 1 by 3 means 0.3, sorry. 1 by 2 means 0.5. This is 1 by 4, 0.25. So B3 is smaller amongst. Where is B3? Yeah, B3. Next B1. B2 is highest. B2 is highest. Which will come? B2 is highest. And here also 4 I did. Oh, okay. Is B2 correct only? Wait. 3 ones are 3 minus 1, 2 by 3. 2 will go 2 times. 2 3s are 6, right? I told 6 only in, okay. This is 6 only, yes. 1 by 6. 1 by 6 means 1. It is 0.1. Okay. Enough up to 0.1 because it's 1 by 6. So which is least? B2 is least. B2 least, after B1 will be, no, after B3 will be, after B1 will be. B3 will be in the middle. Correct? Keep on doing carefully. Semicircular loop of radius 30 centimeters. R is equal to 30 centimeter wire carries a current I is equal to 6 amperes. In uniform magnetic field B is equal to 0.5 Tesla. Present perpendicular to the plane of the loop. What is the magnitude of force exerted on the wire? Force F is equal to semicircular loop of radius 30 centimeter. Wire carries 6 amperes of current. and uniform magnetic field of 0.5 Tesla is present perpendicular to the plane of the paper. This is magnetic field B. Semicircular loop is like this. So effective distance is this one. Effective distance will be 2r. So F is equal to BIL and B value is 0.5, I is equal to 6, L equal to 2r, L equal to 2r. 2r means 60 centimeter into 10 to the power of minus 2. So 10 will be 5 into 6 into 6 into 10 to the power of minus 2. 180 into 10 to the power of minus 2. 1.8. Yeah. Next. A long straight wire carrying current I is equal to 16 amperes bent at 90 degrees such that half of the wire lies along the positive x-axis. 16 ampere is bent at 90 degrees. Bent 90 degrees. Half of the wire lies along the positive x-axis and the other half lies along the positive y-axis. Okay. What is the magnitude of magnetic field at minus 2i here and 0? Minus 2i comma 0, 0, 0. That this point only, right? Here only. Here magnetic field. For this wire along this point only. So no magnetic field contribution. Only this wire's contribution only. 16 amperes bent at 90 degrees. So maybe it's an infinite long wire, long straight wire. So mu naught I by 4r is the formula. Mu naught 4 pi into 10 to the power of minus 7, mu naught I by 4 pi r. Yes. I value 16 by 4 pi, r value r 2. So that will be 4 pi gets cancelled. It will be 8 into 10 to the power of minus 7 or 80 micro Tesla. Millimeter distance into 10 power minus 3 I have to write. So plus 3 will come. So 8 into 10 to the power of minus 4. Yeah, 8 into 10 to the power of minus 4. That means 0.8 millitesla. No, is 0.8 10 to the power of minus 3 Tesla. So option B. Two long parallel straight metal wires A and B carrying current 12 amperes and 36 amperes. I1 is equal to 12 amperes. I2 is equal to 36 amperes respectively in the same direction are separated by 50 centimeter. Separated by D is equal to 50 centimeter into 10 power minus 2. A point relative to A where the resultant magnetic induction between the two wires due to the currents is 0. Both wires are having A and B have in the same direction. Okay, this is one conductor, this is another conductor, distance D is given already. At which point, see, because of this magnetic field will be inwards, because of this magnetic field will be outwards. So here you can have a null point at x. X is equal to D by I2 by I1 plus 1. So D value 50 centimeter, answer will come in centimeters. I2 is 36, I1 is equal to 12 plus 1. So from first onwards it will come. So 3 plus 1 is 4, 50 by 4. 50 by 4 is 12.5 centimeter. There you are going to have 0 magnetic field induction. 0 magnetic field induction. A uniform magnetic field B is perpendicular to the plane of the circular loop of diameter 10 centimeter. Circular loop of diameter 10 centimeter. Okay. Diameter 10 centimeter. And from wire of diameter 2 mm, resistivity from a diameter D equal to 2 mm, resistivity rho is equal to 2 into 10 to the power of minus 8. If a current of 11 amperes is to be induced in the loop, I need a current I is equal to 11 amperes. Rate at which B is to be changed. The rate at which B is to be changed. So dB by dt is equal. Okay, this wire this wire only, okay, this wire only, the diameter 2 mm and resistivity this one. So this wire only, not a thin wire, it's a thick wire. dB by dt is equal to how much? To have this much of induced current I. Okay. Induced current I is equal to 11 amperes. Okay. Resistivity rho is equal to 2 into 10 to the power of minus 8. And area is equal to pi d square by 4. Pi d square by 4. So I can have the voltage. How? V is equal to IR, that is equal to I, R is equal to rho L by A. So I is there, A is there, L is 2 pi R only, and rho is there. So V will come. V is equal to minus di by dt, L di by dt, of course. Rate at which it has to be changed, he is asking, right? Yes. And L value not given. So EMF is equal to, EMF induced is equal to, EMF induced is equal to dV by dt. I can take NA cos theta will be 1 only, number of turns is 1 only, NA dB by dt. So here area gets cancelled, no need to calculate, so that should be taken care so that it will be done easily. So NBA cos theta, because flux phi is equal to NBA cos theta, isn't it? So cos theta value maximum you can take, N value number of turns and everything, so that I can write it as N is number of turns 1 only, so I don't want to write N. So B A into dB by dt, A into dB by dt is equal to I rho LA. That means dB by dt is equal to I rho L by A square. I rho L by A square, I value 11 amperes, rho value 2 into 10 power minus 8, 2 into 10 power minus 8, 2 into 10 to the power of minus 8, L 2 pi R, 2 pi R value, R 2 pi R is 5 centimeter, 5 into 10 power minus 2, 2 pi R by A square, A is pi d square by 4, pi d square, wait, pi by 4, d square, diameter 10 centimeter, 10 into 10 to the power of minus 2 square, and this is power 4. Why? Because this is A square is there, that's why. So it should be simplified. Then you can have dB by dt. Then can we go forward? It's calculated value I have. Which question it is? Yes, A by R into dB by dt. The same formula and same substitution. You can have it as 2.8 Tesla. Can have it as 2.8 Tesla. 2.8 Tesla per second. The same procedure. Next. An isosceles triangle current loop is kept perpendicularly in a uniform magnetic field B0 in the figure. The force on the loop due to magnetic field is, force on the loop due to magnetic field is, force on the loop due to magnetic field is, loop, isosceles triangular. Okay. Let me draw the picture. This is one side, this is another side, this is another side. This is L. Okay, isosceles, not equilateral. Okay, this is theta, this is also theta. Okay, this one, this is just L, and this. If it is L, these two are different, right? Okay, but this one and this one's effective is also, hey, observe very carefully. Suppose say this is A and this is B. A to B effective length, if you consider A to B, one length is L. This is one length L. And there is another effective length because of the two conductors is, because of the two conductors, another effective length. another effective length, that is current will come like this for that. This is this way. So effective length will be L effective total is equal to 0. So automatically force is equal to 0 then. That is equal to, yeah. A toroid has a non-ferromagnetic core of inner radius R1 is equal to 24, outer radius 25 centimeter. This is outer radius R2, and number of turns N is equal to 4900 turns of the wire wound. If the current of I is equal to 12 amperes is flowing through that, then what hit the magnetic field? B is equal to mu naught Ni, that is equal to mu naught number of turns per unit length into I, that is nothing but mu naught N by 2 pi R into I, and R is equal to average you have to take. Average is 24 plus 25 by 2 is 24.5 centimeter, and you need to convert it. So B is equal to 4 pi into 10 to the power of minus 7, number of turns 4900 into I is equal to 12 amperes by 2 pi R. 2 pi R value is 24.5 into 10 to the power of minus 2. So B is equal to two infinitely long wires each carrying the same current and pointing in y direction are placed in xy plane at x equal to minus 2 and x is equal to 1. Suppose two infinitely long wires. One is, this is 0, this is x equal to minus 2 I can call, and this is x is equal to 1. Okay. X equal to minus 2, x equal to 1. An electron is fired with the speed u from the origin, making an angle 45 degrees with the x-axis. Electron is fired like this at 45 degrees. Okay. With velocity u. Then force on the electron at the instant it fired is, force is equal to BQV, right? BQV sin theta, even you can take the angle between this. See, these wires are along y direction. One wire is like this, another wire is also having same directional current. Check. Infinitely two wires carrying same current and pointing in y direction are placed the same direction. So what is the net magnet and current? Current is given. Two infinitely long wires each carrying the same current and pointing in y direction. Current value is given. B naught is the magnitude of field at origin due to the wire x is equal to 1 centimeter alone. So B is equal to B naught is equal to mu naught I by 2 pi R. 2 pi R is x is equal to 1, 2 pi 1. This is substituted formula, so that B naught is equal to, he gave mu naught I by 2 pi. What is the direction of this? It is along y axis, so k direction. So B naught means this one. What about magnetic field due to the other conductor, second conductor? Second conductor is mu naught I by, this is inwards, that means minus k direction, mu naught I by distance 2 pi into distance from the origin is 2 units only. Yeah. So this can be, I can call minus B naught by 2. Minus B naught by 2 is this one. So what is net magnetic field? Net magnetic field is equal to, this is minus B naught by 2 k cap. So one is B naught, one is minus B naught by 2. B naught minus B naught by 2 k direction. So if you think it is B naught by 2 k cap. So k direction, it is thrown 45 degrees, but even 90 degrees only, because wait, what did he say? Okay, we will do like this only. This is 45 degrees, means velocity I want to take like this. Velocity u bar is equal to u cos 45i plus u sin 45j. Then it will become 1 by root 2, u by root 2 of I plus j. Now happily you can go for the force. force F is equal to Q into V bar cross B bar. That will be better. Q is electron into V bar cross B bar. V bar cross B bar. What is V bar? V is U by root 2 into I plus J cross B naught by 2 K cap. So E U B naught by 2 root 2 into I cross K J cross K minus I. So J minus I minus I minus J with minus sign, I minus J with minus sign. First option is almost all, no, it's close, it's true, first option. And what happened to by 2 root 2? What happened to by 2 root 2? I need to check. By 2 root 2 is there, option D. Minus I minus J. Oh, it's printed wrong. Huh? It's printed wrong. Maybe typing. Let me check the question number. Just a minute. Okay, it's correct only. Just in a minute, I'll change it and I'll continue. Yeah, option A. Next. It's running, right? Okay, let me continue. Yeah, a wire of length L meter carrying current I ampere is bent in the form of a circle. L is bent in the form of a circle 2 pi r. Magnitude of its magnetic moment is equal to, because it's having current I in the form of a circle. Magnetic moment B is equal to INA. I is I only, N is one turn only, area is pi r square. So I pi r is L by 2 pi square. That is equal to I pi L square by 4 pi square. So this is L square I by 4 pi. L square I by 4 pi. Which of the following case no force exerted by a magnetic field on the charge? Moving with constant velocity, there is a force. Moving in a circle, there will be a force. At rest, no force. So option C. So next. Current I flows in a circular arc of radius r, making an angle theta. In the figure, find the magnetic field at the center. O will be theta by 2 pi into mu naught I by 2r. Mu naught I by 2r. This is full actually. Okay, current is flowing in the same direction. Fine. So theta by 2 pi. So first option, mu naught I by 4 pi r. Yeah. It's next. Checking is having some difficulty. Yeah. Two long parallel conducting wires contain currents are separated by distance x. Work done per unit length in changing the distance between the wires is proportional to. Two long parallel conducting wires carrying currents are separated by distance x. Then force between them F is equal to mu naught I1 I2 by 2 pi. Suppose say 2 pi x only. This is force per length actually. Force per length is mu naught I1 I2 by 2 pi x. Work done per unit length in changing the distance through dx. So work done is equal to dw. dw is equal to F by L into dx. This force is attractive. Suppose in that direction or in opposite direction we are applying for displacement dx. Then this is going to become W is equal to integral of mu naught I1 I2 by 2 pi x dx. So that is equal to mu naught I1 I2 by 2 pi into log x with base e. Log x with base e. So it's proportional to log x with base e. Option C. Next. A moving coil galvanometer converted into an ammeter of range 0 to I is equal to 5 milliamps. Okay, the galvanometer resistance G is equal to 90 ohm and the shunt resistance S is equal to 10 ohm. If there are 50 divisions in the galvanometer turned ammeter on either sides of 0, its current sensitivity is, continue. Current sensitivity of galvanometer he asked, that means theta by d theta by di of the galvanometer we want, that means theta by Ig we want, theta by Ig we want, okay. But Ig is equal to, we have S is equal to G by n minus 1, S equal to G by n minus 1, S is equal to 10, G value 90 by n minus 1, implies n minus 1 is equal to 9, n equal to 10, n equal to I by Ig actually, I by Ig, I by Ig is 10, I value 5 milliamps, then Ig is equal to 5 milliamps by 10, so 1 by 2 milliamp, Ig is okay. Now this is 1 by 10 milliamp, 1 by 10 milliamp, yeah. Now theta, that is sensitivity equal to theta 100 divisions, because 50 on either sides, 100. Hey, what is this? Not 1 by 10, it's 1 by 2, it's 1 by 2, by 2, 50 divisions on either side. Then this is 0.5 on one side and 0.5 on other side, so I took only 0.5, automatically I have to take only 50 only, not 100, because then in that case I have to 10 milliamps, right? That's why. So it is theta value 50 divisions out of half milliamp. This is 100 into 10 to the power of 3 then in divisions per ampere. So that is equal to 10 to the power of 5 divisions per ampere. So option B correct only. Option B or D? Divisions per ampere is correct. D option, yes. Next. Torque acting on a magnetic dipole placed in a uniform magnetic field is 0. Torque equal to 0 when the angle between the dipole axis and the magnetic field is, dipole axis and the magnetic, tau is equal to mb sin theta, isn't it? Equal to 0. So theta equal to 0 degrees. mb sin theta is the formula. Next. A charged particle is subjected to acceleration in a cyclotron as shown in the figure. The charged particle undergoes increase in its speed only in the gap between d1 and d2 because the electric field will be there. In the magnetic field, speed will not be increased, only direction is changed. So option A. And next, a proton moves with a velocity v bar is equal to 5 into 10 to the power of 6 j cap through a uniform magnetic field, uniform electric field. Obviously magnetic field also will be there. 0.2 into I plus 0.2 j plus k, and E bar is equal to 4 into 10 to the power of 6 into 2i plus 0.2 j plus 0.1 k. Okay, what's his problem? The approximate force on the proton means charge q is equal to plus E. Approximate force F is equal to q into V bar cross B bar. You need to go for 1.6 into 10 to the power of minus 19 into, we have to go for I, J, K, V bar cross B bar. V bar, oi. This is Lorentz force. Not only this, we have some other story. Q into V bar cross B bar plus E bar also there. Plus E bar because it's a Lorentz force. Enjoy. So V bar cross B bar first I'm doing. Okay. V bar cross B bar. V bar is just 0 and 5 into 10 to the power of 6, this is also 0. B bar cross B bar. B bar is here 1, here minus 0.2, and here 1, and here you can multiplication factor 0.2 is there, I can take up. Yeah, next plus, and this is into E bar. E bar whatever is there that you have to, and simplify. Don't want to waste the time. Next, galvanometer resistance G is equal to 50 ohm connected to a battery of 3 volt. V is equal to 3 volt along with a resistance R is equal to 2950 ohm in series. Full scale deflection 30 divisions. Full scale is 30 divisions in the galvanometer. In order to reduce the deflection to 20 divisions, the resistance in series is, you need to read the question very carefully. Resistance in series, already 2950 is there. Some more will come. These two you have to add and you have to tell. 3 volt is giving for 30 divisions. We want, if 3 volt comes for only 20 divisions, suppose, then for 30 divisions how much will come? If 3 volt comes for 20 divisions, this is actually VZ, galvanometer one. If 3 volt comes to 20 divisions only, then for 30 divisions how much will come? Because both must be to the same divisions, right? That's why. So 3 volt by 20 into 30. So it is going to become 9 by 2. 9 by 2 volts, 4.5 volts. Yes, this is V. Now N is equal to V by VZ. V by VZ is V value 3, V value 9 by 2. V value 9 by 2, Vg is 3. So this will be 3 by 2. 3 by 2 means 1.5. 1.5 is N. Now R to be added further for this is G into N minus 1. G value not 50, 50 plus 2950, total 3000. For that I have to add total 3000. So for that I have to add 3000 into N minus 1. N minus 1 is 1.5 minus 1. That is 1 by 2 into 3000. So that is 1500 ohms further added. So 1500 plus 2950 will be how much? 50 and 4450 will be the resistance in series. Next, the resistance in series should be, and this is 4450. How much? 2950 plus 15. 4450 is correct answer, but I will verify once and I will change. 4450 correct only, Chotus. It's a correction in the key. 26th one it is. I'm going to change it. This one only. Yeah. 4450. Don't panic even after watching. Be confident at your calculation, otherwise check your calculation and then cross verify. But after double verification only you can decide whether it's wrong or not. Okay. So yes, this is 4450. Next, total resistance will be 4500. Already existing series resistance 2950, to be added 1500. So carefully you answer whatever he is asking. Which of the field pattern given below is valid for electric field as well as for magnetic field? Both. Emerging, converging, loops. Loops are possible for the both. Loops are possible for the both. That is a maximum possibility. A toroid wings N turns has inner and outer radii R1 and R2 respectively. Okay, it carries certain current I. The variation of magnetic field due to the toroid with radial distance is correctly given by, inside the toroid magnetic field is constant, that is B equal to mu naught Ni. Then option D is the possible one. It is not going to change, and outside will be 0, and toroid whatever the other spaces it will be 0. See, toroid means like this. Here magnetic field is 0. Here also field is 0. Here is uniform field. It is going to have uniform field. We are going to have. So obviously, option D should come, right? Yeah, option D. Yeah? Option D. Else. A strong magnetic field is applied on a stationary electron. Stationary electron won't respond to magnetic field. Then the electron moves in the direction of field, moves in opposite to the, remains stationary. That is option C. Yes, don't think wildly that it spins. Stationary electron won't respond to magnetic field. A cyclotron used to accelerate proton, deuteron, alpha particle while existing under similar conditions. Exiting. While exiting under similar conditions, the minimum Ke is gained by cyclotron. Minimum Ke is given by R is equal to mv by bq. We have mv by bq. We have. So here you can write P is equal to square root of 2mke by bq. I can write. So under similar conditions means maybe radius same, magnetic field same. So kinetic energy I can write like this: RBQ. I'll put squares for them so that I can write 2m here, so that I can write Ke here. So Ke can influence only here q square by m. Ke is proportional to q square by m. Now let us have proton 1 1, deuteron 1 2, alpha particle 2 4. These are masses, these are charges. So q square by m, q square by m, 1 2 4. So this is 1 is to 1 by 2 is to 1. 1 is to 1 by 4, 1 by 2 is to 1. The minimum Ke is gained by the middle one, deuteron. So option A. Next. Okay, end of the session. Keep on practicing. We'll discuss another chapter in the next session. Bye. Have a nice day. Be focused. Practice.